This is Mahoney's podcast 6.2. We're at the top of page 6 in our Unit 6 packet. Today we're going to be calculating our empirical formulas. You're going to need your calculators, you're going to need periodic table, and the packet, and that should about do it. So let's look what an empirical formula is. They are your simplest formulas. And when we start, so what that must mean then is that we're going to have a different type of a formula if we have to define this one. And on Friday, we will be looking at molecular formulas and looking a little bit more at the difference. So right now, the only one we know is empirical, and that's your simplest ratio. Now, if it's an ionic compound, we're going to find out empirical and molecular are the same. Covalence can have many different multiples of the same base. So right now we're just calculating that base formula or the empirical formula. So let's look at some of these steps. And at first the steps seem like they don't make sense. I just want you to write them down, and then when we do them you can look back and kind of reference them and you understand. These actually aren't hard. They're actually kind of fun, and we're going to do an activity tomorrow and see if we're going to play a little bit of CSI and see if you can figure out who killed who and how by figuring out the compounds. So let's look at our steps. First thing, we need to have grams. Sometimes this is already done. If so, you go yay. Okay. If not, if you're given a percent, the easiest way is just assume you have a 100-gram sample, and yes, this is fine, you can do this, and then your percentage is just going to be a gram. Because if I have a 25% of a 100-gram sample, that means there's 25 grams. 13.3% of a 100-gram sample is 13.3%. So really it's just change the percentage into a gram, but this is how you can justify it. This is why, because that's true. If you want to make your math really difficult, you could assume you had a 1,000-gram sample and then convert it to grams, but I'm all for the easy. Second thing, grams are worthless. We cannot skip this step, because I have to compare the ratios. But the only way I can do that is in chemistry. The moles, this is what we can do, is kind of like our common denominator. So we have to convert grams to moles. And remember, use the molar mass to do that. The next step, you're going to divide all the answers by the element with the smallest number of moles, or your smallest molar value. Because the reason, again, we need to get whole numbers. This step probably seems a little confusing, but don't just say, wait, I don't get it. Let's figure out when we practice it, then it's going to make sense. But again, I just want to kind of write down some of the steps so when you go back and look at a problem, you understand what we're doing. So let's just practice one. So this is your very first problem, and this is how they're going to look. This is what you're going to be looking for. The empirical formula. When we start doing molecular, that's how you differentiate and to know what do I need to do. So look what I have. Percentage. I have 3 different elements, but what we said is let's just change that percentage into a gram by pretending I just have a 100-gram sample. Because the compositions are the same, that means the grams will be the same. So you write out, and yes, this is how I even do them. What do I have? Sodium, I have sulfur, and I have oxygen. Write this out. If you play shortcuts, you're going to get really confused. So what do I have? I have 32.38 grams of sodium. I have 22.65 grams of sulfur and 44.99 grams of oxygen. Okay, that was the first step. Step 2, change them to moles. Well, the molar mass of sodium, and we'll just go ahead and use 3 significant figures, and then that's a nice straight line. And then for sulfur, 32.1 grams, oxygen, 16. This is how you guys are going to start to learn those molar masses. Okay, now significant figures. They really don't matter on these, because what you're going to see is we're going to divide things out. But do not shortcut. So on these, I actually even write myself out to 4 significant figures, because if you start rounding and rounding, you're going to not get the answers, and it's going to drive you crazy. So no shortcuts. Write at least a minimum 3. I think 4 is much better. because then you're just a little bit more accurate in your results. Okay, so this was the math. 32.38 divided by 23, 1.48. So that's how I got these answers. I just did the math. Okay, now technically what I could say then is, okay, here's my answer. So for sodium we have 1.41 moles and sulfur is 0.7056 and oxygen is 2.812. I don't think we've ever written a formula like that. So we need to get these two whole numbers. So look at these values. Whichever value is the smallest, you divide everything by the smallest. And what happens then, moles will cancel. And we know at least we're going to get one number because we know this will be at least 1. So divide everything by the smallest, moles. Okay, so if I do this, that is 2, that one was 1, that one is 4. Now I know on your calculators, like, wait a minute, this is really what? 1.995. Okay, that's close enough to 2. This one was 3.985. Okay, again, 3.99s, 1.99s, round them up. So that's why I rounded that to 4, rounded it to 2. That just told me my formula. So I have 2 sodiums, Na2SO4, 1 sulfur, and 4 oxygens. This compound is sodium sulfate. Let's do another one. Okay, find the empirical formula of a compound, and I'm looking at this. I have 2 grams of iron. Excuse me, it's already in grams. I have 53.7 grams of iron and 56.3 grams of sulfur. Sometimes you might think, oh, I can take a shortcut. I know what the formula is going to be, but I can't on this because I have different irons. I need to figure out which iron it is. So what do? I write down how much I have. Okay, first step I didn't even have to do. You had grams, you just started with second step. Second step, change them to moles. 55.8 grams, sulfur 32.1 grams. So find out how many moles you have of each. 0.9624 moles of iron, and it's 1.442 moles. Next step, look at these. Divide by the smallest. 0.9624 moles. 0.9624. So this I know will go to 1. Okay, now this one, if I get this, it's like 1.49 or 1.5. Okay, I can't round that. 1.9s, 2.03s, 1.97s, I can round that. I can't round this. So then we have to go, okay, what will I multiply? Think of almost like a fraction. So this is like 1.5 or 3 halves. How do you get rid of a fraction? Multiply it by its reciprocal. So the reciprocal of a half is 2. And what you do to one thing, you have to do to everything because you have to keep everything in the same proportion, same ratios. So I'm just going to multiply everything by 2. So when you multiply this by 2, you get 2. 1.1.5 times 2, can I squeeze it in here? That's going to be a 3. So this is my formula. It tells me I have 2 irons and 3 sulfurs. This is iron, Roman numeral 3, sulfide. So this iron has the +3 charge. So you might be going, okay, but when do I need to do this? So let's kind of go back. Oop, there it is. Jot this down somewhere. And these are kind of to know the some of the decimals you're going to see. Don't worry, you're only going to pretty much see halves, thirds, and fourths. So if you see something ending with a decimal of a half, and again, may not be exactly 0.5, it might be 0.51, 0.498. If you're close to the halves, you can't round it. You multiply everything by 2. Okay, thirds. So if you have that 0.33, and again, it doesn't have to be exactly 0.33, 0.32, 0.34. Think of it as a third. You're going to multiply everything by 3. Same thing with the 2/3. So 0.66s, 0.67s, 0.65s, multiply everything by 3. And then you might see a quarter in there somewhere, so the 0.25s, you would multiply it by 4. I will say probably the most common are probably halves and thirds. But just know if you get it something, I couldn't round these. These are all ones that I couldn't round. You would have to multiply, and what you multiply to one thing, you're going to multiply to everything to keep it all consistent. Okay, well, I want you to work on number 3. And then again, that's where we're going to start tomorrow, that we can practice it. And again, they take a little bit of time. You won't have to do 10 of these on a quiz, but they're not really hard, but you just have to make sure you go through the steps, be patient, show your work, and like I said, they're fun because you're just really doing a formula, doing percent composition backwards. You're puzzle solving, figuring out what the compound is. See you tomorrow.